Hello everyone, this is Mr. H again and welcome back to my YouTube channel. In this video, I will be discussing with you compound interest. In this video, we'll be covering both the exponential and logarithmic equations. So I do hope that you finish watching the entire video. And before we get straight to the very first example, let's take a look at some important concepts that we need to know to answer a few examples later on. All right, so to calculate the compound interest of an amount that is paid more than once a year, we need to use this formula. Future value will be equal to the principal amount or the present value multiplied by 1 plus the rate divided by the number of times the interest is compounded per year, which is raised to n times t, where t is the number of years. Compound interest is an application of exponential function, specifically exponential growth. Because as you can see here, this is what we call the growth factor. So you have the 1 plus r divided by n. Earlier, I mentioned that this video will be covering both the exponential and logarithmic equation. So basically, half of the examples that we will be covering in this video will be talking about the application of logarithmic equations, in which if t is missing or the number of years is being asked in the question, definitely that's the time when we will be using the logarithmic concept. All right, so let's jump straight to the very first example. Tamara deposits $7,000 into her savings account, paying 8% annual interest compounded monthly. How much money will her savings account have after 10 years? All right, so first of all, we need to take a look at the given problem. And if it's possible for you, you need to be able to distinguish what information was actually given that you will be using to calculate and solve the given problem. All right. So basically, for this question, we were given the present value or the principal amount, which is $7,000. So that is our present value or the P. Also, we were given the interest rate, which is 8%. So that's ER. And it's also stated here that the interest will be compounded monthly. So this is actually a clue. That's our N. And another thing is we have this time period, 10 years. So that's our T. And the question asks, how much money will her savings account have? So basically, we're asked for the future value. All right. So after identifying all the information given, then we can proceed with solving the question by using the formula that I presented earlier, which was the future value will be equal to the present value or the principal amount times 1 plus r divided by n to the power of n times t. The future value, what's being asked, and the principal amount is 7,000 times 1 plus the rate is 8%. So it's all up to you if you write it in percent or in decimal. So n is equal to 12 because it's compounded monthly to the power of 12 times 10. All right, so we carry on simplifying. So future value will be equal to 7,000. So 1 plus 8% divided by 12 to the power of 120. All right, so I have an advice for you here. Since you will be allowed to use calculator for this one, you need to type all this information in one go. So if you type all these numbers in one go on your calculator, it's going to give you an exact value of 15,537.48164. And since we're talking about money here, definitely you can write your final answer into two decimal places. But then again, it will always depend on the instructions, how you are asked to write the final answer. Okay, so future value approximately equal to, say, 15,537.48. So that is the answer. So if you're going to interpret that value, so after 10 years, Tamara's savings account will have $15,537.48. All right, so that's for question number one. And for question number two, how much money would you need to deposit today at 7% annual interest compounded semi-annually to have $11,500 in your bank account after 11 over 2 years? So first, let's identify the given information. So you have here the interest rate, that's 7%, and it says it's compounded semi-annually. In every compound interest problem, definitely you will have this uh, compounded annually. So if it's annually, n will be equal to 1. So that's once a year or yearly. So if you have semi-annually, so n will be equal to 2, right? So you will also encounter quarterly. So quarterly will be the word quarter, so n will be equal to 4. Also compounded monthly, so we already had that example in question number 1, n will be equal to 12. Okay, so if it's daily, it's 365. So if it's hourly, so you get the gist, right? But basically, I think that in real life, I don't think that there are banks that would do that, daily or hourly whatsoever. Okay, so these are the usual. Okay, all right, so going back to the question, or annual interest of 7%, compounded semi-annually. So semi-annually will be n equals 2. And here, so this is actually your future value, right? This is future value. And if you go back to the very first part of the question, it says, how much money would you need to deposit today? So that means that the present value or the principal amount is missing. You were given the future value, and also the time period or the number of years will be 11 over 2 years. All right, so we're going to go back to the formula that we need to use. So we have the future value will be equal to the principal amount or the present value times 1 plus r divided by n to the power of n times t. So then simply substitute the given information. So future value is 11,500 will be equal to p stays the same because that's what we are solving for. So you have 1 plus the rate is 7%. So we can write 0.07 in decimal form. divided by 2 because it's compounded semi-annually, to the power of n, which is 2 times year. So year is 11 over 2. And next we can carry on simplifying the right-hand side of the equation. So p times 1 plus 0.07 divided by 2 to the power of, so 2 times 11 over 2 is 11. All right. So at this stage, it's so clear that we can divide both sides by this factor, okay, to find p. All right. So we can divide both sides by 1 plus 0.07 divided by 2 to the power of 11. We also do that on the right, on the left hand side. All right. So this one divided by this, it's going to give us 1. So it's going to be 1p. That's going to be left on the right hand side. Okay. And from here, you can actually see that, right? That will be p equals 11,500 divided by the whole thing. So 1 plus 0.07 divided by 2 to the power of 11. You need to type this whole thing on your calculator. Okay, like everything in one go. All right. And if you do that, it's going to give you the exact value of 7,876.875708. That is the actual answer. Okay. But then again, since we're talking about here money, and again, it depends on what the instructions are. Okay. So you can leave, we can leave our answer in two decimal places. Okay. So the value of P, or the principal amount, will be approximately equal to 7,876. Okay, so $7,876 and say 88 cents. So to interpret this answer, this is how much you need to deposit now in order for you to have a future value of $11,500 following this interest rate, compounded semi-annually, and 5.5 years. All right. So those first two examples talk about the application of exponential equations. All right. So for the third and fourth example, so those are the last two examples, we will be applying the concept of logarithmic equations. All right, so you need to recall properties of logarithm. All right, so let's take a look at question number 3. All right, so for question number 3, Timothy deposits $15,700 into his account at a 9.5% per annum interest compounded quarterly. How long will it take for his account to have $30,000? So for this one, it's very clear that the question is asking for the number of years. How long will it take for his account to have $30,000? So we're looking for the value of t. Like what I mentioned earlier, if the question is asking about the number of years, or how long will it take for this money to grow and stuff like that, definitely that's when you need to apply the concept of logarithm. All right. So we were given the principal amount, which is 15,700. So you have the interest rate, 9.5%. So that's the R. And it says compounded quarterly. So it says compounded quarterly. Definitely the value of n here will be equal to 4. Okay. And we were given also the future value, which is $30,000. Okay, so the formula is future value equals to the principal amount times 1 plus r divided by n to the power of n times t. So future value is 30,000 equals, so the principal is 15,700 times 1 plus the rate is 9.5% divided by 4 because n is equal to 4 compounded quarterly to the power of 4 times t, which is 4t. Okay, and from here we can divide both sides by 15,700. So 15,700 divided by 15,700. So that's going to cancel out, or it's equal to 1. So the left hand side is 30,000 divided by 15,700. It's going to give us, okay, so we can simplify that by having like 300 over 157. So we can keep it that way. All right. And for the right hand side, we are left with this whole thing. Okay. So we just simply copy that. All right. So we can simplify whatever is in the parentheses, right? So simplifying whatever is inside the parentheses or the base. So it's going to give us 1.02375. Now, so if you type this whole thing, the base on your calculator, you need to write everything. Okay. And then from here, this is where we will be applying the concept or one of the properties of logarithm. Okay. So to be able to start solving, we need to take the log of both sides. So remember, you are dealing with an equation. So whatever you do on the left must also be done on the right hand side. So I did take the log of both sides. And from here, so from here, we can have, I can just copy the left-hand side, which is log 300 over 157 will be equal to the right-hand side. This is where we will be applying another property, okay? So in which 4t, which is the power, will be put to front, okay? So I hope that you still remember the properties of log. Okay, so this power 40 will be put to the front. It looks like it will be the coefficient of the log. Okay, so 40 log of 1.02375. All right, and then from here you can see that we can divide both sides here. So we can divide both sides here by log of 1.02375. And log of 1.02375 divided by log of 1.02375. So it's going to give us 1, or just simply cancel. And the right hand side will give us 4t. And we just simply copy everything on the left hand side. At this point, the left hand side of the equation, you need to type everything on your calculator in one go. Okay? So if you do that, that is going to give you 27.58720361. So 27.58720361 will be equal to 4t. From here, it's so clear that for us to find the value of t, we need to divide both sides by 4. So it's going to give us t. So 27, this whole thing divided by 4 is going to give us 6.8968000903. This is the actual answer. Okay. Now, so depending on what the requirement is, definitely here you can leave your answer in one decimal place. So I can say that the value of t will be approximately equal to 6.9, let's say 6.9 years. All right, let's jump straight to our very last example, which is still the application solving logarithmic equations. How long will it take to double your money in your savings account if the bank pays a 4% annual interest compounded monthly? So basically, for this question, maybe you notice that, oh, there's no principal amount given, only the interest rate, how many times the interest will be compounded, right? Which is compounded monthly. So just giving us an idea that this is the rate, and this is the value of n, and n will be equal to 12 because it's compounded monthly. But since there's no specific number given, definitely you can set your own principal value, and whatever your principal value, the present value is, or the principal amount, then just double it. Okay. All right. So let's say I will let my principal amount be 500, say $500. So the future value, since it says double your money, definitely the future value will be $1,000. So 500 times 2 is 1,000. And these are the numbers that I will be plugging into the formula. Okay. All right. So it's going to be future value will be equal to the principal amount, or the present value, times 1 plus r divided by n to the power of n times t. So the future value is 1,000 equals 500 times 1 plus the rate is 4%. So that's 4%, or 0.04. It's all up to you. Compounded monthly. So n will be equal to 12 to the power of 12 times t, which is 12t. And then from here, you can divide both sides first by 500. So 500 divided by 500 will be canceled out, or it's just equal to 1. So 1,000 divided by 500 is 2. And then we're left with 1 plus 4% divided by 12 to the power of 12t. Okay. All right. So you can simplify whatever is inside the parentheses or the base. So will be 2. So you need to type this whole thing on your calculator. And if you do that, it's going to give you 301 over 300 to the power of 12t. Okay, and then from here we can take the log of both sides. So this is where the log kicks in. So log of 2 will be equal to, so 12t will be put forward, down. So it's going to be 12t times log of 301 over 300. And then we divide both sides from here by log of 301 divided by 300. So this will become 1. Just cancel it out. And the right hand side will give us 12t will be equal to log 2 divided by log 301 divided by 300. And then on your calculator, you need to type everything on the left hand side in one go. And if you do that, it's going to give you 208.2905355 equals 12t. And then from here, to be able to find the value of t, we need to divide both sides by 12. Okay, so 12 divided by 12 is 1, so it's 1t, or you just cancel it out. And 208.2905355 divided by 12, so type everything on one go on your calculator, and it's going to give you an exact value of 17.35754463. Okay, and we can conclude that the value of t will be approximately equal to 17.4. So one decimal place, 17.4 years. So I hope you learned something from this video. If you did learn something new, please give me a thumbs up, share the video, and if you haven't subscribed yet to my channel, so please do subscribe. It's Math Hub by Mr. H. And once again, thank you very much for supporting my channel, and I'll see you on my next video. Bye, guys.